is question number 8 of November 2020, paper 1. And in part A, we're asked to show that sine of x tangent of x over 1 minus cosine of x is equal to 1 plus 1 over cosine of x. So how should we go about to solving this? Well, I guess you can write sine of x, you can write tangent of x in terms of sine and cosine, and then multiply that by sine of x, so it's going to be sine of x over cosine of x, 1 minus cosine of x, right? Then you can use trig identities, so we know sine squared of x is equal to 1 minus cosine squared of x over cosine of x times 1 minus cosine of x. Now you can simplify this, or you can expand it, whatever you like to call it, as 1 minus cosine of x times 1 plus cosine of x. And then we, in the denominator, we'll just have cosine of x times 1 minus cosine of x. So your 1 minus cosine of x will cancel out, and you'll be simply left with 1 plus cosine of x over cosine of x. So that'll equal to 1 plus 1 over cosine of x. On part B, we're asked to determine the range of values of k for which sine of x tangent of x over 1 minus cosine of x is equal to k and has no real solutions. Alright, so 1 over 1 cosine of x equal to k, and 1 over cosine of x will equal to k minus 1. What else? So cosine of x is equal to 1 over k minus 1. Right, so we want this solution right here to have no real solutions. In other words, it should be a complex number, and so that only happens if k is equal to 1, that's going to be 1 over 0, which approaches infinity, right? So I guess 0 less than k, and then the upper limit should probably be, so if it's 2 minus 1, it's going to be 1. Therefore your cosine will be valid here, it will have a real solution. So I guess the values for k should be 0 less than k less than 2. So you can see I didn't put an equal sign because I'm specifying that it should be less than and greater than 0 and less than 2.